refresher on that. ECMA, what is ECMA? ES6 classes, subclassing, superclass, setters and getters, static methods. So when you see the syntax, you won't be lost when we're talking about React. I remember with ECMA definition was that international organization that deals with the specification of JavaScript. We already know what JavaScript is, high-level untyped programming language. This body of organized body, ECMA, they have all the different schemas. As we know, ES6 was the big release. And we looked at the various other subsequent versions, ES7, ES8, ES9, smaller releases, but standardizations, no doubt. Sometimes I think ECMA International might look like this, where they sit around a table. I hope it doesn't look. I hope it's not like this, right? Because there would be certainly consequences to going against the schema, I guess, of the charter. All right, so prototype chain. This we never really we may have talked a little bit about what the prototype chain was. That was JavaScript's way of doing inheritance. It's not true inheritance. It's JavaScript's version. Because JavaScript has that one construct called objects to work with. So with an object, each one has a private property which holds a link to another object called a prototype. So as you have, no matter what it is, whether your object is, some built-in, built-in object or something that you defined, it comes with this possible prototype to link to if you wanted to. Sometimes you'll often see when you're debugging that there's a proto there. And sometimes you can actually attach things to it in more advanced JavaScript. But anyhow, it just has a prototype object that also within it has a prototype of its own, and so on and so forth. This chain can grow until finally you hit a prototype that has a null, which is the final link. And so it is very confusing. That's why I didn't really delve deep into it. It's very confusing, but some people consider it JavaScript's biggest weakness, but it's actually very powerful. Some people would say more than the classical model of OOP, right, object-oriented programming, because it's so wide open that's why you see so many frameworks, so many different ways to create JavaScript libraries and things like that, because people can take vanilla JavaScript and just kind of build on top of it and extend things to however they want, right? There's no barriers per se, right? So that's why you'll see these explosions of different types of frameworks and probably more to come. This is kind of what it looks like if you wanted to really visualize an object that has a property. Now prop, we're gonna say that a lot when we deal with React. Property, it's a property, right? This is your object, but there's this link to the prototype chain, often empty. Right away, it'll have like a null link, so it won't go anywhere. You'll just see it sometimes in your debugger, and you'll wonder, what is it? I don't know what it is, right? But if you wanted to attach something to it somewhere in your code, you could attach something to it. So you can see here, somebody attached a property to the prototype chain. Somebody also made another link to another prototype and then linked another prop. So it has this chain, but if somebody's working with your object, they can just access object one, property one, dot property two, dot property three, and it'll know where, it'll try to find it in the prototype chain. So in a way, that's how it does its own object-oriented behind the scenes. If somebody did, in fact, create a constructor function with the capital, right? We will, again, when we're doing React with functional components, this is the pattern. And we contain, some of these properties within it with this keyword, and then we have this object. This is our way we create our object. We could later on in our code attach a middle name to it. So I don't know why I put name here, but person.proto.middle name, we're adding a middle name to it. So the takeaway here is you could have a library that has, maybe it's not your code, maybe it's just some library that you've inherited from. It could be jQuery autocomplete for all we care about, right? It could be autocomplete or some widget and we just want to add to it. We don't want to mess up the existing library. Maybe we want to add to it. So we could add to the prototype if it has one, and then we could put what we want in there if we wanted to extend it that much. But we don't need to worry about that, to be honest. We can deal with classes. We can think about, I mean, again, ES6 with the abstraction around giving us syntax that we feel we know, syntactic sugar, right? I think I showed you with the Babel compiler what it looks like. So we ran a class with a Babel compiler, and then it showed us what it outputted behind the scenes was all prototype chain anyhow, right? But because it's so confusing, we have now these declarations that we can work with that is similar to what we know in a strongly typed language like C#, Java, and all these types of things, right? Small talk, anyone? I started in university at IBM Small Talk, and I remember I was totally lost the first week because it's a extremely different way of thinking. Now I live and breathe this stuff. It's so second nature, right? But anyhow, JavaScript classes, that was in ES6, ECMAScript 2015, same year, same way of saying it. Basically, that's sugar around JavaScript so that we don't have to deal with that prototype-based inheritance. We can work with classes. When it compiles with the Babel compiler, it'll convert it back to that chain, but we don't need to worry about that. We're going to write our code. We are going to, it's a little limited, right? It's not exactly the same it doesn't have everything out of the box. It does come with a class syntax, and it does come with some of these other keywords as well. So this class syntax does not introduce a new object-oriented inheritance model. No, it is just a prototype-based inheritance behind the scene. Functional declarations are hoisted, class declarations are not. So that's a good thing, right? We don't get that hoisting happening, that when we define it, it gets thrown into the top of the script. Same deal as our functional declaration, our name functions and our functional expressions. You can just do inline, you can just do class rectangle. Again, what's important, especially for React, is that we have that capitalization happening to signal that it's not just a normal function. This in fact is a class that's required. And then we have some keywords there: constructor, which allows the initial setup of this object. We have this keyword, of course, and then we can do the expression, right? To be honest, I usually use the class declaration mostly, but you can also define it in this way, right? You give the variable name, and then you just assign it directly to a class, right? Subclassing. So then we may also need to extend. So before I jump ahead to that, let's look at some code. And there was a question here. I didn't even see it. Basic. Yes, basic small talk. We still need to be able to understand prototype in order to understand others' code. We do need to understand the prototype chain, but you won't need prototype with React because we won't be necessarily using it, right? It's good to certainly know for vanilla JavaScript exactly what it does, and working with it. And to your point, we should dig deeper into it. It'd be a good example to do, right? So I'll have to find a good example on that, write that down. But geared towards React, I can't say I really use prototypes very much now. That's not to say when I'm doing React coding, because it's so close to JavaScript, you mix so much vanilla JavaScript into your React coding, especially if you have a hybrid model where you have a lot of vanilla JavaScript that orchestrates the React, then you're dealing with everything, right? You're dealing with everything that we learned about in terms of DOM manipulation, in terms of prototype. You have everything, right? And you also have React. We'll talk about that more. So anyhow, Here's a class, person class. We have a constructor that takes a name and age, sets them internally using this keyword. And then we have a method. So if you notice here, it's a function, but you won't, in a React class component, you won't necessarily have function inside, function inside of there, right? You'll see right away that unexpected token. It's not expecting that because these are, if we are dealing with the syntactic sugar of a class, an object, this would be called a method, right? If you remember, methods are the actions. Methods are the actions and the behaviors. The properties are the characteristics of your class. So we have a class, right? We have a class, and it's a signature of what an object could be, because we may need to create multiple objects from this signature. How do we do that? We create an instance of it. So we need to new it up. So we have that keyword there. So we can create a new person. We new it up. So this is Sarah, and we can call that method from in that. If we wanted to create, object, a different, an entirely different object, right? We would have to new it up as well. And this could be some random, I don't know, admin, and I don't know what the admin is. 4 years old, and we're just going to new it up, and then we're going to reference it again in the same way. And we know from past experience that this instance is different than, so whatever is contained in here is like an encapsulated object, so that when we go create another object, it is its own instance of that encapsulated object. So this is reusability now. We can continue to use this signature for 100 objects to whatever we may need. We don't need to keep creating it every single time, right? So that's review. Now, one thing to note about ES6 is, the newer versions of the JavaScript schema is that, yes, we do have class and objects and kind of like this inheritance, this object-oriented feeling, but there is no such thing in JavaScript or ES6, 7, 8, 9 as interface. If you don't know what interface is, it's basically a very, very, very scaled down version of, it's not an object or a class. It's basically just a signature that you cannot create an abstraction or an instance of it. You can just refer to it to enforce that class has this kind of criteria. Very, very common in object-oriented programming, but JavaScript does not have that. So they're dealing with prototype chain and behind the scenes, meaning classes, objects that need to be derived, right? So when we do this creating instance, it's deriving. All right, so if we had that and we wanted to come around here and just say, all right, I like the fact that I have this person class, but I want to create a customer. I want to, in fact, again, remember our solid principles. I honestly forget. Okay, the solid principles was more advanced in terms of object-oriented programming. I don't know if we went over them, but single responsibility, open, close, Liskov principle, interface. Sorry, what was that? Interface segregation, dependency injection, something like that. Around those. That's a good exam question. The pillars of object-oriented was polymorphism, right? So we want to be able to have many types. So if we wanted to take this person class and we wanted to, it's great. Maybe this would be shape. I want to have how many shapes, right? We just extend it. This other keyword extends it. If we want to, it's always good practice to call into this parent to let them know what's going on. So we have this super construct. This super construct will pass up name and age so that name and age are visible to the subclass. The subclass inherits everything in here. So anything inside of there is part of the customer now. And the customer just does one more thing. It adds a new field called balance. Now remember, the person class doesn't know anything about balance. It exists at this lower level, and so does this new method called info. Well, you can see here, it references the parent name, and it says he owes me whatever, $60, right? And then if I instantiate this guy, all right, so let's actually run this and see, give it a go. Remember, right click into terminal window. Don't know why my terminal's not opening here. Integrate terminal window. Let's take a look at this guy and run him. Right, node demo 4. Object is not defined. All right, so I probably did something else here. Object's not defined. Okay, that makes a lot of sense. We'll just define this guy as object. Okay, cool. And we will just run this again, right? So my name is Sarah, I'm 28. My name is admin, and I'm 40. If you notice, those were these person objects here, but now we have this customer. So now we have this customer. We want to invoke console log, and we want to invoke customer dot, and his method is info. So we have that guy. If you noticed as well, console log, I won't assign these anything. Customer also has access to age, balance, name. So he has access to its parent superclass properties. It also has available to it the greet method. If I wanted to call it greet method, it comes along for the ride, which is very useful if you're doing something as generic as a shape, or maybe you have, whatever. What would be very generic for a shape? Number of sides, right? Number of sides of a shape would apply to almost everything but a circle. You get my drift? So you would do something generic, then you would be specific. Specification on the derived classes would be, okay, what is the area of this square? That doesn't apply to all shapes. So you can see there, we get these other two invocations here of that customer. Question is object-oriented programming still popular? I have heard about AOP and functional programming. It depends on it really depends on your job or your skill set. In Java and C# and strongly typed languages, yes, OOP is very popular still, and it's very much in use, and you need to think in that way. When you start moving towards the front end, then not so much. Then you're dealing with functional programming, you're dealing with this JavaScript kind of quasi-OOP. It all depends on your technology stack, right? Strongly typed languages, yes. Loosely typed languages, probably not. What is better in the marketplace? I would say try to know both if you can. All right, so let's recap this. So we have this subclassing with this new keyword called extends. You can see there, it's expressive to create a class and create a child of it. So we have class of animal, and it speaks with that method there. And then of course, something specific would be a dog. And we extend here, a dog is an animal, polymorphic. And a dog is an animal, but not every animal is a dog, right? Every dog is an animal, but not every animal is a dog. This is where I remember learning this stuff, I would be like so confused about this stuff, right? But just know that once you have that signature or that template, the template of what an animal should be, breathing, running, sleeping, these kind of things, then you can be more specific to what type of animal, what type of car you have. And you might have a car, you extend it into a class of a car. Maybe the class would be an electric vehicle. From then you can extend the electric vehicle into whatever model it is, Tesla, GM, I don't know, whatever, right? You can, that's how you get more specific. The dog can speak, but you notice here in this situation here, so this is interesting, right? So you have the parent, it's also you're also able to do something in object-oriented programming in JavaScript here in the same way. You can overwrite the default behavior. So the default behavior is animal makes a noise, but we have a dog now, so we want to be specific. We want to say when we do speak, the dog, this object, the dog will say barks. So there's a way to overwrite functionality in the same way as if you're using React. React, if you had a class, say a component, it has a bunch of methods in there that maybe you just want to override, or maybe they're just signatures waiting for you to override them. So maybe you want to handle how, the component renders or what happens when it updates. You can override it so that within your object, you have customization or custom logic that occurs at that time, right? You can see there an invocation there, an instance of a new dog. You can see there Mitzi and then d.speak, Mitzi barks. So it will call this piece here. It'll override and ignore the default behavior. If you had previously had a instance of an animal and it was whatever you assigned it to, and you did animal.speak, it'll not know anything about this, and it'll call this method. Super. So it's always good to let the super class, the parent class, know what's going on. At least that it may have some properties you need to set. It is also just it's a good practice in your constructor to, even if you have an empty constructor, to just invoke the super constructor. Not needed, but you'll usually see it's a good practice. But most importantly, if you need to pass things through, you would have a constructor that passes through the name. So you can see here, they didn't do that. So you can see that's basically going to call the super. I think that's missing there. I think there should be a constructor that takes the name and then passes up to super. That's how I read it. I always look for that. Anyhow, let's just say that's there. If we wanted to override this behavior of the superclass that has speak, we override it in here, but we also like what this does. So we can actually invocate the superclass by saying super.speak. So when somebody calls lion.speak down here, this line will call, which is, okay, console log, this makes a noise. And then we also add our own logic here, but he also roars, right? So this is contained within the lion, and we are not modifying that template, right? When I used to do a lot of work, I struggled with how to deal with, when I was learning object-oriented programming, how does this, I would have a gigantic parent abstract class, and I would try to put everything I could in that class. I would put everything, and then what would happen is if I changed it for some functionality, I would break a whole bunch of other stuff, right? So over time, you learn that sometimes maybe you need to have two different classes, right? Maybe you need to, this is where it gets more advanced, right? Maybe you need to create one as the base class, and you have another one that extends that, and then you do different levels, right? But this comes with time and practice. It's super confusing if you're just learning it. Will this work in the lion class because the name variable is part of the cat class? It should. So should it be called super.name? Let's look at that example there. This .name, you're right. That should probably be super.name there. In fact, that should be. Let's look at my example. You're right. But let's run it. Let's take a chance here. All right. So we have actually no. So we actually, that's what's missing though. You see that's what's missing, is there should be a constructor there that has the name coming through. That's what's missing, sorry, in that slide there. So if you look at this here, when I have the constructor name, age, and balance here, I am passing it up to the superclass, right? And then I'm also calling it here, right? Now, so let's check. What happens if we didn't pass it through? Should it work? Let's see. We won't pass it to the super. So what happened here? It didn't like it. You're right. This thought, so accessing super must be called, must call super constructor. So it's forcing me to call the super constructor. So this example right here is missing the super, and you would get that if you actually ran it. So it's actually invoking me to say, yes, you must pass in that. So what happens if we called an empty constructor, right? So that every object should have an empty constructor, right? So you can see now we passed in name, but the superclass did not actually get access to it. We can call this .name, so my bad, we can call it without doing super.name, but it's undefined right now. See if you see that there, it's undefined. Therefore, we need, what happens if we passed in name and run this guy, then you'll see the name is populated from the, because I'm extending from the class, from the parent, I do have access, because this, I guess, is still part of the person class, right? So we do have access to it. But it will enforce the fact that you need the super. So you could have the empty constructor, but that property will never be set. So therefore, this will be undefined, right? You still have access to it, but it's not set. It's really undefined. So really, it's not, there's no value. So it'll enforce the fact that you need to have a superclass, which is good. You should remember that pattern. Because not all languages expect you or enforce you to call the base class constructor. But it gets very, very tricky when you start really thinking about objects. But at the very least, understand the extends, because you're going to have components that extend the functionality from React components. Static methods, we won't really be using static methods very much, but it's worth noting that you could have a static method. If you don't know what a static method is, in normal object-oriented programming and strongly typed languages, is you don't necessarily need to create an instance of it. You can just call it, you can call it the class itself. It lives in memory. Usually static methods live in as a singleton in memory. What does that mean? Don't worry about it right now. But basically, what's a good utility methods, right? Log4net, logger. Maybe you have error, I don't know, you have some type of error map, error library like Bugsnag or something like that, or maybe log4, what else am I thinking about? Auto mapper or mapping functionalities, you have that. So those are really good just to be, they don't change much, so that you can just quickly call them as helper methods. So you can see there, I have a class with a static method. I give this this keyword as a static. And if you notice there, I'm not, in this example, we're not instantiating it. We don't have to do the wire up to say this is a new object. We just say class with static method, call it directly. We don't need to create instances. Same thing here. Couple static methods, we just call them one-off. So really great if you wanted to log something really quickly. I don't often use static methods too much unless it is the situation where it doesn't change very much. And you need it to live globally in memory, perhaps, and it needs to be quickly accessed. We won't really be using them, just know they're there while we're talking about this. And was that it? Was there another one? I think there was, I guess that was it. Okay. There were also, I didn't have that slide as well, but there are also getter and setters, but they work similar to getting properties in and out in a way. But we won't necessarily use that as well. So let me just stop there for a second. Stop that recording.